Hello, everyone. Here. Hello. Hey. All right. Thank you for coming, guys. All right. So we have to start now. A few people stay on the way coming, but yeah. All right. Sorry for keep you guys waiting. We should start at 6. Yeah. All right. So welcome to Seven Peaks. Maybe some of you is the first time here. So you see, like we have a lot of events like meetups every month. So this is the cloud meetup in this month, December. We also have like a lot of like activities before as well. Like last month, we also collaborating with some like internship programs, and also we have like PKJS communities. We have all the meetups, like we have internet speaker, and also we sometimes we invite like external speaker as well. So today we have 2 internal speaker and 1 like external guest speaker, right? And like please try to follow and like our social media. It's on the Facebook and also the LinkedIn, because like we always share the good updaters articles for you guys to learn like what is going on in the market. And also we sharing a lot of case studies, and also we have like some activities on the social media, like we also advertising our upcoming events, so you can catch up like what's going on in the SMB software, what kind of activities, what kind of events we are organizing. Yeah, please follow on the LinkedIn and also from the Facebook. You can also find us on the Instagram, I think. Yeah. All right, so we are Walker, and also, yeah, of course, Birdie Harder. So we have a lot of activities here at 7 Weeks. Yeah, things like this photo is like taken last year Christmas party in our old office. We moved to this building this year, like in middle of this year. So we've been here more than 4 or 5 months already, and we have a lot of activities here. Not only that, we also have like every Friday, like we have a TGIF Friday verse, and also we have like internet activities, we have the parties, and also sometimes we're going out, like outgoing party in the outside restaurants. And we also did a lot of sports. We have a lot of club in our company. We have some, gymnastic, the group. We go into gym together. So some like a CrossFit fitness. And also every Friday, we have like activities playing the game together with the PlayStation and Xbox with the, free flow beer here. Yeah, so we did a lot of sports, not only like actual sports, we also do esports. Yeah, everything like you're interested here, people like we try to organize the activities. Yeah, and yeah, we also eat hard. Yeah, eat hard as well. We have like in our company we have like a free buffet lunch every Thursday. So we have like 22 different nationalities working together in this office. So we try to encourage like different cuisine, different culture, to introduce our internet people to taste like different a taste and different culture. So we are enjoying like a food like salad, and also we have like wine tasting activities, and also sometimes we have like vegan week, like sometimes we like vegetarian. Yeah, because we support to any religious and any culture here. Yeah, of course, we are hiring more people. As someone asked me before meetup, like what kind of people we are hiring. We hiring the cool people like you guys. Just only that if you have passions to grow your career, somewhere fit in with international cultures. Yeah, you are more than welcome to apply any position. We have currently we are urgently looking for the .NET developers, and also we have Android developers. Of course, we use some specific technology like Kotlin, and we're also looking for more React, front-end developer, cloud architect, iOS, QA, full stack. If you yourself really interested to explore the new career path with the growing technology community in Thailand, yeah, feel free to send your CV to our email jobs@7 software, or you can also visit on our website career page. We have more than 10 position opening every day, so you can apply any position. Or maybe if you think some of your friends looking for the job to do the same company shrinking down, you can also recommend them to apply and try with us. For the upcoming event, you can also check on our social media, Facebook, LinkedIn, IG, or you can also scan this QR. It will goes to our event page. And for the next month, we might have a mobile events like meetups, mobile iOS meetups. So, all right. So I would like to invite our first speaker, our head of cloud architect, Giorgio. Welcome, Giorgio.
Yes, okay. Give me the yes. Thank you to be here, guys. Automation. We wait the technical time to. Thank you very much. You choose the right one. Yes. Thanks. 1, 2, 3. Fantastic. Okay. Now, what we are going to speak for these sessions about the architecture of the microservice. Who I am, very shortly. I started to work in IT long time ago, and this is all the list of my roles. Here, this is our cloud team, where we have this certification and more, because the slide is not so big to contain everything. So I put the most notorious and famous one. Okay, what we are going to 7 speaks today. Okay, definition. What is a microservice, or what is a possible definition of a microservice? We need to understand what is a microservice. The definition is the most easy concept that we can give to you to say, okay, this is a microservice. What is the possible mistakes? And here, guys, will be a sort of funny part of the presentation. I will show you what is the common services for the Azure and AWS to use when you are going to implement the microservices. Okay, we start. Definition. What is a microservice? Taking this definition from the microservice.io, a microservices, also known as microservice architecture, just here some bell should be ring, is an architectural style that structures an application as a collection of services that are highly maintainable and testable, loosely coupled, independently deployable, organized around business capability, and the most hard part of this sentence is capabilities, owned by a small team. Everyone knows what is a small team. It's not one man, at least it's 2. Okay, meaning, what the definition means. Microservice architecture is a style, not an application pattern or structure. Is a style. The architecture decide the components or module or microservice, and the style design the behavior of these components. Okay, Giorgio, what doesn't mean that? That the microservice is an architecture. This architecture is built by modules or component, and these components are placed in this place where you take, because they have a specific behavior. What I mean as behavior? HTTP GET www.google.com as the behavior to load the index page of Google. Now, how it works, what is the scalable feature, the resilience, affordability, blah, 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 is something that belongs to the architecture of the microservice. but the behavior is load the index of Google that yesterday was down. Yeah. Not happens only to us. A 500 error by Google. I was so happy. Something go wrong. Loosely coupled. What does it mean? I put this together. Someone remember what is the SOA architecture or know what is the SOA architecture? SOA is the acronym for the service-oriented architecture. The SOA architecture, if you put a P here, is SOA protocol that is based on the XML for the first web services. SOA architecture is built over a simple concept of three actors. Provider, so who provide the service, like the server of Google. Consumer, me. Registry. The registry contains, let me say, the registry can be the DNS in this case, where I want Google, give me the IP of Google to make possible the communication. So the three actors is who consume the service, who provide the service, who tell to the consumer how reach the provider. This is the base of the SOA architecture. Is a simple concept replicated all the time in all the possible architecture of the last 20 years. Communication. Okay. Loosely coupled. If two microservices or two components of the same microservice architecture is not interconnected for some strange reason, and one component need the other one to elaborate his behavior, to fulfill his behavior, they need to communicate. This part of the communication is often is the big issues of the design of microservice, because the communication should be auto-contained. One message should be every information that the other microservice need to do what he have to do. After should be fast as possible, because I want the index page of Google. So remember that in this definition, remember the concept of the SOA architecture and the communication among them. Easy to maintain and test. Easy. Easy. The word that I smile is easy, not test, easy. Owned by a small team. I put together all these sentences because here the microservice should be clear and well-defined structure. Everyone that work in the small team, should be the laser, yes, okay. Everyone that work in the small team should be know what kind of component do what. How, okay, but authentication is this component. Okay, good. Now, how do that can be optional, but you already know that if I have some kind of issues in the login, this is the component that provide the login or fulfill the behavior to allow the user to log in themselves. The wall of tears. I call this section wall of tears because these mistakes happen, and when you ask to the guy, sorry, but this is why you make this mistake, they start to cry because they have a lot of regrets to say, yes, but happen that yes, but you create a mistake, maybe you need to do engineering everything here. So why you make this mistake? Because the condition of the project was like that, I am under pressure, and so on. I call this section in that way because when you ask why, they start to cry. and they fix these errors, these mistakes, is very painful. So they cry more. Okay, guys, here I want your end. Admin only on dev. Keep it until production. This is, sorry, what is the database, the password database? Password. Okay, John Doe drop my database. Why? Because the password is password, or the password is admin. Fantastic. What kind of password you are using for your database? Okay, you are in the right place. Okay, good. Okay, guys, I make this as joke, but these mistakes is not admin, okay, but violate any possible security concept that you have. First of all, at least privileges. Why you need to connect as admin? I can understand, but admin is not your role. I'm sorry. Or admin, the password weaknesses. Make a password longer, put some space, use a phrase of your favorite movie. Welcome back, Mr. Anderson. We miss you. Is a phrase, but you can, there is the space, there is the exclamation point at the end. You can consider as secure. This is what I say. Testing. I have a product that they don't have testing. What? Sorry? There is no testing procedure. The only testing procedure is login. Works? Yes. Fantastic. Okay, good. In production, and one day, there is the PM, the project manager, the customer, who is in production. We have this error X. With X is a aleatoric variable. Can we fix it? We don't know. Black hole. Boo. Can we go outside, play around something other else instead of spend time here? Because there is no test. The test is not the bored activity that you have to do because my PR should be approved. It's because when you have the error X in production, the test can help you. And if you don't write the test, maybe you need to spend hours and hours on debugging just to replicate the simple error X that maybe can depend or can escalate in error Y, zeta, W, ABC, and so on. So please, at least write one test, not the login. Logging. No audit. The security without no audit is something that is very not good to have. John Doe drop on my database, remember that. The application don't have logging. The log file exists, but is redirect on dev null. Fantastic, it's the most common place to put the log. Why you did that? Because we consume a lot of space. Wait a second, why dev null? There is also dev random, dev zero. At least you have the log that is zero. You write something. Dev null, no. Choose another device, choose another memory area, something like that, but dev null, no. There is someone that have the log of their application that point on dev null. Why? Because we don't have space. Maybe something is wrong in this logging system. Okay, no log. What's happen if I have no log or just a bit of the log? You waste time on debugging. Why waste time? Yes, maybe you can find the issue that is not logged, but maybe this issue is the peak of the iceberg of one implementation bug or implementation issues. So think in this way. I fix this bug, but I don't take the computational method, the computational flow. So I cannot see if my implementation is wrong or not. These chaos bring, I waste time on the debugging, because for every case, for the error X, error Y, error Z, for me it's like the Poisson process, restart always from zero. Maybe a bug is a single case that don't solve the issue, what I say now. Okay, now I confuse you very well. And this is was my goal. So, microservice is an architecture, is a style where you divide your application in module. You need to define the behavior of this module and need to define or specify very well the behavior for each module, what is the communication among them, and the responsibility for each, the responsibility or the goal for each flow of the communication. And so architecture. Everyone should be know or should be have a point of reference to call to say, I am the consumer, registry, please give me the provider of this service. Logging and testing. If in your microservice architecture you have a workflow that have more or less more than 5, 6 steps and communication among the other one, if you don't have test or logging, you can forget to put this in production, because you have something that you cannot manage. And John Doe drop the database, okay, but this is normal. Okay, so when you have clear this concept, fantastic, you need to choose your cloud provider. We start with Azure. Azure Service Fabric. What is a fabric? Yes, okay. It's a fabric of the service that stay inside Azure. Yes, okay, good. Service Fabric is the first microservice service, that cover exactly the SOA architecture. When you deploy something, this something can ask to the fabric, I want the module of the email. The registry of the fabric tell him, okay, the email is here, this is the IP, this is the public DNS name maybe, or this is the private DNS name, you need to use this protocol. Stop. Done. And help you to organize the orchestration, the monitoring, that is part of the logging, the auto-scaling, and provide you the dev and ops tool, plus this beautiful plugin that is, for me, from my point of view, I judge very powerful, because you can connect on the service fabric, say, okay, I am the dev machine 1, 2, 3, 4. Oh, is the laptop of Giorgio. I want to connect with the email or the computational module or the service for the accounting, whatever. Can give me this kind of module? Can I enter in this orchestration? Yes, no. Give me the permission. You are no one, for example. Or is a microservice is developed by small team, and this team can have maybe not the admin password. And this is something that, okay, good, this machine don't have the admin password, can enter, or something like that. Is a permission over your dev machine that cannot touch, for example, the generation of the salary of the people, sometimes. Okay, can be extended to the on-premise data center, can be interconnected with the other cloud, blah, 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 but this is, for me, enter all in the auto-scaling and in the DevOps. Guys, who know Google Anthos or Anthos? No, depends. I don't want to enter in the Greek lesson. Is the concept that Google follow. Okay, Google create Kubernetes. They master this technology. Say, why we cannot extend this concept also whatever and ever? The Azure Service Fabric do the same. Before was the server, after was the virtual machine, now is the container. Easy. Is always registry, consumer, and producer. Not escape by this. This is more or less how work in the bird view the service fabric. I'm sorry. There is the application type that is the as type is not have a double meaning. First meaning is type as behavior. This application create the report, example. This application provide the authentication. Second meaning is the type, is REST, is gRPC, use the SMTP protocol, and so on, okay? This is the service that this application can use. So this application cannot use service 2, but can use only service 3, 4, 5. My dev machine can use only service 2. Okay, you can see that. And for every services you have, I don't know what is that code, have the configuration and have also the data. Unfortunately, admin here doesn't work. Password 1, 2, 3, 4, yes, works. Okay, logging. This monster is the Azure monitor. You can start from here to the top or from the top to the bottom. The Azure, according the level of the login that you want, provide this kind of service. You will find everything inside that. You can, for example, there is the telemetry of the computational part. You can visualize by this service. You can analyze by this other service that this service created that, and this can create the alert or the auto-scaling triggers, or can be integrated with the other external resource. For example, you have in your company, you have your custom logging or monitoring system. No one say no. Okay, if you use Azure, you cannot use that. This is very helpful, especially for when in combination with this dashboard and application. I give you a situation. You develop your best application as microservice. You perform all your tests. Okay, all is good, fantastic. We need to put in production. When you click deploy and he give success, the first wish, the first desire that you have is what fuck is going on? 1, 2, and 3. If you are using that for the testing and check what is going on the test, you have already everything. For example, Black Friday, you deploy the new promotional stuff. What's happened? My beautiful, the CPU of that stay here, of the dashboard, of my, for example, logging mechanism or the identity service, spike up. How many possible users can have? Okay, CPU spike up. I have here that I have 5 instances and start to scaling another 3. So guys, maybe we have a lot of user. Go here, cross the data of the logging with the order, maybe, okay, the purchase that you register in your e-commerce. And you have, okay, I have 1,000 users that is registered, I have 2 sale. It's not a Black Friday, this is called an attack. It's something other else. Trigger alert, emergency, emergency, emergency. Okay, security. Security, what does it mean? No, okay. Is the Azure is based over the concept of the Active Directory, AAD, Azure Active Directory. This kind of stuff give you the availability to manage identity and permission over this beautiful landscape. This is only the most principal one. Okay, that here there is also Firebase. There is the inside here. There is Salesforce. Yes, Salesforce is here. There is Google. There is the other service that is extended, like Oracle and so on. My own business application. These help you to manage the permission that you have. My dev machine no need to enter here, for example. Can speak only with the Office 365 and cannot speak with Facebook, for example. Have an integration with external service and can be defined an identity governance. You need to go there at this moment. Tomorrow today you are the admin. Tomorrow that we go in production, you are no one. This is the more or less in 3 words the governance. I can assign you permission over the identity and the application, or on demand or on runtime. According this, I want to enter. Sorry if I go back. There is the integration here. I have an attack. Okay. Scale down. All these users that now is entering start to deny everything. So the possible attacker have 404. Only if go in the other page or click on buy now, I can accept. So this is a real user that I want preserve in. The other one remove everything. The combination of this and the combination of this make that. You specify the behavior. This is the producer. This is the consumer. Quits is a surprise. Question number 1. Did Giorgio miss to mention the Azure serverless services? Yes? No? Who is Giorgio? The question is wrong. None of above. What is your possible question answer? More than one, if you want. Who is Giorgio? Okay, my favorite is that. Who is Giorgio? I meet every time. I meet every day in front of the mirror. Yes, I miss to mention what is the Azure serverless. And the question is a bit wrong. Why I miss? Because maybe the serverless, if you choose the serverless for your microservice architecture, don't have the paradigm of the SOA architecture, don't define very well the behavior of your component, and you need to provide a lot of services to make the orchestration or the organization of your component. I remember you that some serverless services in Azure is stateless. So can be good when you send an email or produce a report. Can be good in that way, but how integrate in my services? I don't know. Need to ask to Giorgio. But who is Giorgio? Question number 2. Easy. Did not you miss to understand what is a microservice? Yes? No? I don't care because I copy and paste. I have to think more. None of above. What is your question? PEX for you is none of above. We know that. Okay. Marcus, no. You are don't care. You copy and paste. We already know. Yeah, I like this silence. I like this silence. I like the silence. Think about that. Think about that. Honestly, I don't want to listen the answer, but think about that. Because there is a lot of people, developer and so on, that they think to know what is a microservice. But really, they miss all the feature, all the point of the definition that we show in the first slides. Why Giorgio make this question? It's my daily job. I don't know, but I don't know Giorgio, because he wants to help us to understand, because Giorgio is the imposter. These are not questions, are suggestions for me, none of above. I give you this question for the point number 2 and point number 4. This is something that I give to you, hopefully, that help you, and helps for suggestion and for possible enhancement for you. So when I have a microservice, wait, Giorgio say, do that is real? No, fantastic. This is a monolithic application. Good. Works in that way. AWS. How many use AWS here? Nicolas? At least one. Yes, Nicolas, don't care. 1, 2, 3. So don't be ashamed, guys. Not that we cut your hand. No, okay, okay, good. Sorry, you are the speaker. Why you raise the hand? Here, people, the imposter. We have the imposter also in the meetup. Okay, what I have to choose for the microservice in the AWS cloud provider? There is a lot of that, and I can choose the EC2, that is the classic choice for the infrastructure as a service. I can choose the container solution that is called the ACS, the Fargate one, and with the combination of ACR, that is the registry. Otherwise, there is the, okay, here is the slide taken by the AWS documentation. So I no risk to make some mistakes and cry later. This is the infrastructure as a service. This is the platform as a service for the container. For ACS, you have 2 types. The Fargate one, that is the serverless, and the on AC2, that is based on the virtual machine. So you build the cluster in the normal way. You have several nodes to build. ACR is the registry for your container. There is the Lambda and the Lambda at the edge, or Lambda at edge. This is the another serverless AWS services that now is very famous, and Nicola, my colleague, will teach you how use what is the pro and cons, what is the benefit. And this newborn here, that is the Lambda that run on the point of presence of the CDN of AWS. Can be good, can be no. Sometimes this if you specify the behavior of this component, this is very useful. Example, I upload an image. I need to resize this image because I don't want 1 terabyte of image in my database on my storage. So I need to resize according a possible resolution that I want. Okay, I don't need to store this. The Lambda run in the location where the customer enter, in the border gateway, and resize this image. So I try to upload 1 terabyte of image. Before that this 1 terabyte touch my application is scaled to 1 megabyte. This by this guy. Logging. Ne more, ne less. Access log e audit trail. Access log e audit trail, the audit trail is the service. Can be stored into the S3 or somewhere else. Is the service, is the might functionality that say you what is doing that and how. I am during the operation of authentication and I'm using the credential of admin. Okay, this is Giorgio. You can understand. Okay, deny the access to Giorgio. Fantastic, good, works. Security rule number 1, done. Green, via. The service or the log for the computational part that go inside the Amazon CloudWatch. CloudWatch now is like the Azure monitoring, is the central point for the logging of AWS. Have the same power of the Azure monitor, and you can create dashboard, record the log of your application or of the services. You can build the integration according the log that you have in your workflow. For example, application number 1 call service number 2, that call service number 3, that recall application number 2, that recall. This is very good for the microservice if you think. CloudWatch integrate everything. You can cross the log as the log analytics in Azure monitoring, and you can create your alert system or your scale system. This is the agent part that you can reuse by the AWS tool and SDK into the EC2 and the RDS to cross the log here. Example, this from this slide, unfortunately, it's not so clear. How many people have an experience as database administrator or see the log of the database? Not the log of my application against the database, the log that the database produce. Someone see that? No? Maybe? Okay. It's very interesting because give to you that you read when you have a certain kind of confidence what the developer write the query or the store procedure. Why this query spend 100% of the CPU to collect or to fetch all the result? Why the SQL engine should be merge or create the Cartesian product across these two tables and the result is like 1 million of row? This is good log to have. One, because you can go to developer. Sorry, your SQL sucks. Second, help to you to scale. If my query or my log have spend x 10 seconds to be computed, execute, and return me the result, and I have only 100 record, if I scale and I have 1000 record, or more, because we want more, 100,000 record, what's happened? This is for the database. Because the people that increase the number of the cluster of the database. No, doesn't work like that. Amazon EC2. Sometimes in EC2, when the auto-scaling is not immediately, the agent on the machine help you to understand what is going on. What is the timing on the scale? How many virtual memory use? What is the pagination? What is that? What is a lot of information that when you have help you to fit your application. Why? Because the microservice can scale, and I expect that you have 1000 requests per minute or per second. When you have this number, okay guys, we need to have a certain kind of control over the system. Security. Something that, what is the security? Admin, no? So, okay, authorization, authentication. If I say security, what is the first concept that should be appear in your mind? Or if I ask you, what is a security? Give me a definition of the security. Better. Triple A. Authentication, authorization, and audit. For that reason, the Kerberos have three heads. And why this system is called Kerberos. Authentication, this is the service that you can use into AWS. The authorization is here. These three, this beautiful triangle here, is something, because the audit, guys, is here. Audit is here, in this part. There is the service that is called AWS Athena, the English pronunciation is Athena, yes, Athena, that help you to cross and visualize all the log. So you can query, you can cross this log as you want. Attach to the CloudFront, create the alert, remove the permission to Giorgio. Okay, this is the goal, remove my permission. Sorry. This is the service that you can use to increase your security and enforcement and the visibility of the component of your applicational module into your microservice architecture. Yes, another one. Yes, easy. So this is the most common question. What I have to choose for my microservice architecture? AWS Lambda or AWS ACS Fargate or Elastic Beanstalk or EC2? Possible question. All of these four. None of them. Start to roll the dice. I choose only the serverless. I don't care. None of above. I like the third one. Start to roll the dice. I want another. Two, preferably. Why? Can you specify your answer, please? It depends, okay. I can agree. But can you explain why you choose it depends? Mm-hmm. Okay, good. Okay, I ask, Okay, I asked you, what do you think about this question, this answer, to the rest of the audience? Oh, you need to stop to give me the frame over here. I want the audience, not a tapestry, okay? Fantastic. What do you think? It depends, because all the answer of that. You agree or not? Sorry, it's Boolean. True or false? You agree? True or false? That's bad. Communication issue. I don't know. The microservice is yours, guys. It depends. Only if season work with you. Otherwise, no. Yes, this is the possible answer. It's fantastic. It depends. Yes, I agree. Because depends about the behavior of my module, my component. There is some component that is serverless. Why? Because it's stateless. Send an email. It's stateless. Oh, generate a report. You generate this report, start the report, read the data, put this data in that way, stop, produce the PDF, whatever. Yes, can be a Lambda. Yes, it's serverless. Can be an EC2. Can be an a container that run inside the ACS Fargate. Why? Why ACS and not EC2? Because I don't want to configure the EC2. Easy. I put all in the Docker container. I run the Docker container. Done. Finish. Easy. What is required into a microservice architecture? Well define the component and their behaviors. Communication among and between modules. I don't care because I copy and paste. Find the imposters. This is very, very important every time. None of above. For example, there is the guy over there are the imposter of the front end, because they belong to the back end. It's the imposters of the front end. So I don't ask them the front end question. I ask to them the back end question. As I say before, is the first two have more weight than the other. So the microservice don't belongs to the application. In architecture is a style, is an architecture. You need to think on the whole view. What, why, and how. I don't understand the question. They are the imposters. Giorgio is the imposter. Right, Marcus? These are not questions. They are suggestions for me. None of above. Why, how, and what. Oh, what, why, and how. What this module should be done. What this architecture should be fulfilled. Why and how. Why I choose this service? Because it's serverless, because it's stateless, because need to send only one email. How? By the SMTP protocol. What I want in the log. Why I want the log. How I want the log. Timestamp first. Okay. Well, done. One less. Via. I want this information into the log. I want my audit log structured in that way. Why? Because I need to cross with the CloudWatch or Azure Monitor to have my beautiful dashboard or trigger my alarm. Giorgio no need to enter in the database. This is what? Done. Finish. I hope that based on the question, I give you an help into your application of microservice. So I introduce the next speaker, that is my colleague Nicolas. Move, clap your hands. Yeah, Nicolas is here. Eh? And Nicolas bored you across the. But why you choose always this title? You cannot change.
No.
Okay. So the next and previous.
Okay. So hi everybody. So this one is a talk like that will go deep dive in monitoring on Azure specifically. So like Giorgio said, some companies like migrate from monolithic application to microservices. When you are working on a monolithic, it's really simple to set up like everything for monitoring. You install everything on your instance and you keep it as it is. You add the logging in your application, you don't change it, and you install everything is running, and you have your data. But then the question is for microservices. How can you manage the scale? How can you, when you want to run a new application, a new instance, how do you install all the tools that will help you to monitor your infrastructure and add your login and your metrics? So I'm Nicolas, I work here, and I work mainly, yes, on AWS and Azure. And I'm quite of a runner, so if someone is running here, please, you can talk to me. So first, what is monitoring? So there is like the monitoring is kind of confusing for some people. So let's first start with observability. So there is 3 pillars in observability. If you manage and you understand them well, you can monitor your application really efficiently. So the first one in observability is to try to collect as much information as you can at the beginning, because you don't have enough. And mainly when you are in production, what happened to you is like you don't have any information at all. When it's broken or when you have an issue, you don't have enough information. So first, collect as much as you can. Second point is start to think about what you collected. Start to think, oh, maybe this metrics makes sense for me. Or maybe this log makes sense for me. So I want to monitor them and I want to put them in a central location somewhere. That's what we call monitoring. And then with this view, you only have like a kind of a dashboard or what's going on your platform. But you don't really analyze what's inside. You don't predict or so you kind of need to understand the metrics that you are displaying. And that's when you are on the analyzing part where you kind of build alerting system. So once you understand what you want to monitor, you can build an alerting system on top of it. And yes, monitoring tells you whether a system is working, and observability lets you ask why it's not working. So one is like information, and the other one will tell you if it's working or not. But you need to have all the stages. If you have a monitoring dashboard and you don't have the information, you cannot do anything. So let's deep dive. So in the observability, we have like 3 pillars. The first one is the logging. So when you want to like get an information in the application, you want to know, oh, we send a message to an external service. You want to know, maybe I did some computation and I need to display the output and I need to understand what's going on. And there is also the logging on the infrastructure that we should not forget. For example, the Nginx or Apache, everything that is log servers. The second pillar is metrics. Like, I want to understand, for example, on my EC2, how many CPU I use, or what is the RAM that I use on my EC2, on my VM. And I want also to have some metrics in my application internally to say, oh, I spent some time to call the DB, but how much time was it? And the last one, tracing, is also really important and really new for microservices. So tracing is where you want to try to connect the dots. So when you have an application that is split in small modules, you have like some difficulties to find where is the issue. So at the so what you want to do is to kind of retrace where the information is going from the beginning to the end. So you have one request, for example, that comes from your web application, call an API, maybe one microservice, a second microservice, call a DB, then send a message in a queue, and call a microservice and save in a DB. And you want to be able to track where the information is flowing. So that's what we call tracing. So once you manage the three pillars, you can go for the solution to have one dashboard. So think what you want to display, and this one can be customized depending on your need. So you can have one dashboard for example, for your infra team because they want to know how much CPU and RAMs they are using, or one dashboard for the cost because your manager wants to check that everything is properly set up and doesn't cost a lot of money. Or maybe one for the dev team that wants to know if the queue is blocked or if there is any issue with the server itself. And the last point is alerting. So when you are on the observability layer, you are more reactive because you just collect information and you read it. But once you start to understand what is this information, you can start to be proactive and give more information, valuable information, to the one that will use the monitoring. So the question is how to log effectively. So in some application, what we see is, okay, I want to log. I log A, B, 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 or I log whatever, and sometimes the log doesn't make sense. So at scale, what we need to have is to can have a meaningful information in a log. So we should be able, when we read it, to understand it. And it should be also filterable because we have like many services. So the more we have, we need to find a kind of way to filter them. Could be through search services and could be dumped into like huge database, big data. And two last points, purgeable, on-demand, and archivable and secured. So this one is more for compliance. So what you want to be able to do is to say, okay, let's purge all the logs after 3 months because we don't want to keep any personal information. Or you say, oh, I want to archive them because my business is critical and I want to keep all the logs. So let's put them in a secure storage, Glacier or cold storage. And the last one, secure, because now, because of compliance, all the information should be secure by default. That's what we do. So recommendation, don't log any personal information. Log everything that is coming in and out of the platform. So all the requests that comes in and all your external calls. Try to use the decorator pattern in the application. So don't try to make the monitoring too intrusive into your application. It should be something that comes on top, not deep in the application. Otherwise, you will have more difficulty to maintain your application. It will be a nightmare. And this one is a recommendation. When you debug in development, like locally or in your dev server, try to debug without looking at the code, just with a message, and try to find why it happens. Because when you will be in production, you will not have that much information. You will just have maybe one log trace, and that's it. And you will have the version of the code that is deployed, and that's it. So try to play the game in your dev environment. Try to not look at the code and try why it's failing. And once you find it, and you need more information, please add the log. But don't forget to add more information, so next time you don't have to spend a lot of time to do it. And there is different level for logs, so please use them. One recommendation from Giorgio is maybe for the log trace, everything that you want to put as a comment in your code, maybe put them as a log trace. So at least it's useful when you enable the log trace. And give more information. the next one is for the metrics. So metrics is really important too. So in some application, what we see is like you deploy them, it's working, but sometimes they ask, oh, why is it slow? Why is it not working? And because we don't have enough metrics on the services, on the infra side or inside the code. So that's why we need to kind of put this collection of metrics everywhere. And it will help us to detect underuse capacity sometimes and bottlenecks. And then you can also come with some tangible data when you need to talk to your manager or your boss and say, oh, is it like slow because we have that much, maybe, or the CPU is like 100% for 1 hour already. So we can say, oh, maybe we need to horizontal scale the EC2, or maybe we need to, you have more data to give to your third parties. So same advice is to generate as much metric as you can at the beginning and try to scope it down at the end. So and instrumentation is often underestimated. So instrumentation is a way of tracking where the value is going. So this one can be achieved with X-Ray on AWS and Application Insight on Azure. So it's kind of built-in SDK. So tracing. So now we have metrics and logs, but the information is flowing a little bit everywhere. So we want to put them like in a context. So we want to generate an ID at the beginning of the call. So when someone is calling you, you want to generate a kind of correlation ID that will be passed through all the services and that will help the monitoring platform to display you a nice UI where you can see all the flows through the microservices, the databases, and so on. This one should be put at the beginning, so you can early detect when the application is slow and where it's slow and why it's slow. Because sometimes we have some endpoints, let's say for example you have a backend application saved in a DB. And sometimes people say, oh no, it's slow to save in a DB because we have a complex structure. But how do you know? Maybe it's in the code. Maybe you have a for loop that is running for 5 minutes. Who knows? So that's why tracing is really important. You should put it, and then you will have more information on what's going on in your flow. So just an example of some metrics that are important. So for REST API, monitor the response time. So when someone is saying, oh, there is a timeout, you know why and when. You have the 500 to monitor. So why only the 500? Because 500 are server-side error, so your server is crashing. So this one is really important. You should not have any. 400 is client error, so the request is bad. So this one, for me, you can keep it. But 500, you should keep them as minimum as possible. And availability, to know that your system is up and running. For queue system, which is quite it's an integration pattern that we see often in microservices. So when you want to connect from microservice A to microservice B, you either do REST call, but then you tightly couple all the services, the two services. So we can work with a queuing system. So it can be just a simple queue or can be a stream. But what you need to monitor on those is the size of the queue, how many messages is there in a queue, because maybe your consumer is not consuming fast enough. And if you have some systems that put message like aside when it's blocking the queue, just monitor them also to know if there is something that is kind of putting all the message in a dead letter queue and you need to take care of them, because maybe it's some critical messages. So in Azure, it's pretty simple. So everything can be managed first in Application Insight. So Giorgio showed a slide like with more services, log analytics, a lot more services, but you can just start with Application Insight. And then you can extend it with the other tools. So what we want to do is to start with the application insight SDK. So on your mobile and your web app, what you can do is to integrate the SDK. And the SDK will take care of sending the information to application insight here. There is an error here. To application insight. So with this SDK, you can track what are the flows of the users, like I go to page A, to page B, to page C, to page D. Application Insight SDK can track this. What it can track also is like, oh, if the user is on page A, he called 3 REST APIs. It can also tell you this. And then you can use it later for tracking from a page to multiple microservices. Cool. So when you have all the information in application insight, what you can do is to build a dashboard with these metrics. And then you can build your alerting system. So now the next part is monitoring. So monitoring is really to have a view of your system. So it means that you already know your system and what will fail in the future. So if you have a web application, monitor everything that is related to web. So just to recap, you can have different views for your dashboard. So depending on the person, please adapt the dashboard because not everybody wants to look at the same information. So create different dashboard and switch to the needs of the people. And please also secure them with role and permissions. Yeah, and the last point, which is really important, the dashboard should be easily accessible. So we don't want a dashboard that is like somewhere where no one can find it and access it. So this one is the default one from Azure. So this is one of our applications. So for example, I will take here again. So here we monitor all the fail requests. So we can see here, oh, we got a spike maybe this morning. Oh, I need to take a look. And then, oh, we also have like dependency failures. So maybe it's not my system, but an external dependency that is failing. So we can take a look. But overall, my platform is available. So it means like when I call the health check, a server is responding to me. I have a response. But I have something that is failing when I call a specific endpoint, for example. So we need to take a look at this. And you can have also the information about the front end, which is interesting. So yeah, then you can start to create alerts to be proactive. So link your alerts to the dashboard, so then they can have the global view of the system and say, oh, okay, we understand why it's failing. Because when you receive an alert, you don't know why it's failing. You just know that these metrics give you an indication that the system is failing, but you don't know where. Maybe the issue is located somewhere else. So look at your dashboard and get more information. And then you can drill down with the tracing and see, for example, drill down on one specific request and see why it's failing on the road. And the alerts are not spam. So if you use it wrongly, then nobody will take care of the alerts anymore. So don't use it as a spam. So in Azure, you have like different severities from 0 to 4, so 5 levels. What you can do is for each levels, send a notification to different people. And depending on this, you can different type of actions. So how to do this? So what we do here is we also use infrastructure as code. So everything that we create on Azure and AWS is scripted. So when we need to create an application insight, which is a global resource, we need to send an instrumentation key to all the resources that we want to monitor. So we don't go manually and for updating all the services one by one. So what we do is we script everything with Terraform, and then we can easily apply the monitoring on all the resources. Then you can also track what are the modifications on your application, and you can have more kind of monitoring, track what are the modifications. And you can also enforce the retention and security of your data. So we said the log should be secured. The log should be put permission to access to it. So with Terraform, you can enforce this. So yeah, thank you. Maybe question is ace.
Yeah, okay, one question. It's just about when you say you have a dashboard with all your logs and so on. This means that you are storing your data somewhere. How do you manage that you will not store too much data? That because storage is also an issue to care about, right?
Yeah, so the recommendation is at the beginning, if you don't know what you will do or what you will build, try to monitor or gather as much information as you can. And then when you are comfortable with what you measure, just maybe start to work on improving the storage.
Okay, but what if your storage is limited at the beginning? I mean, like, if you monitor everything, like every single request, every single insertion, deletion, let's talk, for example, of a database. If you monitor like everything like that, I think your storage will soon be saturated.
That's I want to say it's kind of the magic of the cloud. So for me, the cloud, when you start a project, should be like a sandbox. So you try everything you want at the beginning. Don't try to spend too much time on cost analysis and try to reduce the cost. Try to build first your platform and what you want to build, and then try to optimize. But at the beginning, anyway, you will not generate like gigabytes of information. So my recommendation is to just go straight, build what you need, and then try to optimize.
Okay, trust you, and I will blame you if it's not the case.
Hi. Okay. So my question basically is related to number of microservice. Like on your first slide that you mentioned that when we decouple right from monolithic application into microservices, right? We're talking about like hundreds of services. How do you manage on that on Azure or on AWS, for example? So if you have, it's possible that you have services, right, that is contain multiple microservices, right? They call each other, right? And you know that something is break, right? And then you need to fix some of the service, but you have thousands of them. How do you manage that effectively?
So basically, I think, yeah. So this is where tracing is important, because you want to see the connection between all the microservices. Because for each microservices, they will have logging, and they will have a metric. You will have the information in each microservices. Okay, I have the log for microservices A, B, C, D, and for my 1000. But this one will help you to link a request and to see from the web application until the one that is failing, or it's failing at the last one. And you will see it with this one. Because what we do is we use the correlation ID that we generate when the front end is calling, and we pass it in the log, in the monitoring, and then you can see all the information you need normally.
I see. So in that case, you know exactly which services has a problem, right? So then, and how you elaborate on that, because you mentioned a good point that I never think that I never used it before. Like you mentioned about you use Terraform into monitoring and do other stuff. Maybe you use it in that way, right? To maybe you can elaborate a little bit on that when you found that okay, so this service has a problem, or maybe multiple services. How you roll out the new one or something like that.
No, I don't know what you want to say.
Okay, this is an example of our application. This is real data. You have some dependencies that here fail. This is a dashboard. So this gives you the high view of the system according these criteria, these metrics. Here, the dependency fail, but my availability don't go down. If I enter here with the system of tracing and all the detail that Nicolas mentioned, you are able to say, okay, this service, this trace, fail on the service 3, 4, something like that, because this service receive this request or this message and have this output. In this way, you are able to understand if the request is wrong or not, is compliant or not with the behavior of this service. Second, the output is real a bug, create a bug, is real an error, or is an error because the response is an error, is wrong, is not compliant with the behavior of this service. And inject the, okay, for the Terraform, for the detail of Terraform, I left to him.
Because I was thinking about something. So the question is also if like you have like 1,000 microservices and 100 that are failing. Yep. So in this dashboard, really, it can be customized because maybe you can have one region that is failing, and that's why you have 100 microservices that are failing. So maybe we should have like a kind of a box to see the availability per region. After you can also put more, like we call one services often on my 100 microservices. We know that we call this service often and it's failing. So put it on your dashboard. But at the end, if there is a huge fail, you need to look into it. It's not magic anyway. Just try to get enough information for you to easily access what you need.
Thank you. Understand that. Yeah.
Eat pizzas and pizza.
Okay. Hello, everyone. Sawadee krap. We are going to start the last presentation of today. My name is José. I will be talking about Blazor in the cloud, how to host a C# single-page application as a static website. Who here, before I start, I want to know who is a .NET developer? Okay, we have 4 people. Who is a JavaScript developer? JavaScript, okay. Who Python, PHP, Ruby, another bucket? Okay. And who don't raise the hand is like not developer or okay, not developer. Okay, what do you do? Okay, interesting. Well, okay, so for today, I know it's a very niche topic. So I try to add as less things as possible about C#, and I try to focus more on the content. Before I start, I would like to introduce myself. Currently I'm working at ThoughtWorks. I like a lot about the philosophy of agile software development. And I'm also a digital entrepreneur. I have few apps by myself. And what I'm going to share with you today will be my experience of building apps as indie developer. When you have like a big team, you have more flexibility to build anything you want for your clients or for your company. You can go for a microservice approach, or you can go with a monolith, or anything else. You have a lot more resource. But in my case, it's only me. And so the question for me is, how can I try to make money with my app as fast as possible, pay as less as possible? Okay, so this one of the solutions that I found was using static websites. So we are going to discuss a bit about how I do and why this approach is efficient. I also use a lot of JavaScript. We are going to talk about WebAssembly and C#, but currently I'm working with Node, using Node.js and TypeScript, basically TypeScript on top of Node. I also speak a little bit of Thai, so if you have any question, or if you don't understand, if you want to practice some Thai with me, I really appreciate. On the weekends, normally I take care of my small projects. I also go around in Bangkok to painting, and I enjoy some of events about a group of people in Thailand. If you want to find more about me, you can search my GitHub, or if you search on Kitchenko on Google, you are going to find me. I also would like to do an invitation for you. We have the .NET Conference Thailand coming 23 January. We'll be at Microsoft. So it's free tickets. So if you're interested to learn more about .NET or Azure or anything about cloud computing, I would like to invite you. You can check the link or the QR code. So the talk for today, we are going to discuss why use Blazor, the reason behind use Blazor, and why to host a static website on a blob storage, right? Why we do that? For some people, is not so logical. You put your web app inside that database, right? But it's a very efficient way to build a web if you have like static content. On the talk today, we are going to cover a bit of cloud. We are going to talk about Blazor and why to host a website on a storage. And for this talk, if you are not a .NET developer, you can use anything about cloud. It will be interesting for you. About hosting a static website as well, you just replace the Blazor by any of framework of your preference. Can be Vue.js, can be Angular. If you are doing Angular, I'm very sorry for you. And also React. Go for React or Vue. Angular, we can discuss about. You can. Yeah. Okay. Since the topic today, the main topic of the event today is Cloud Christmas, I would like to talk a bit about the history of cloud and how the cloud started, right? First, I have a question, like, it's an interview question. Many interviews will ask this for you. What is cloud computing? Or when did it started cloud computing? If people are using cloud computing today, what they used it to use 10 years ago, 15 years ago, where they deploy software? They deploy on the microwaves, the fridge. They have to deploy it somewhere, right? And the point of this is that cloud computing is not something new. The beginning of cloud computing is dated from 1960, in the beginning of the internet, okay? In the projects of ARPANET, the idea started to make the client and server communication. After that, we have mainframes, and we still use mainframes many years, till 2002. On 2002, a retail company, Amazon, had a problem. They use it on Black Friday. They run the service on full capacity, but off peaks, they use only 10% of the processor power. So they spent 4 years to build a system that they could manage and sell the capacity, the computer capacity that they was not using. So something that started on 1960 took 40 years to become the mainstream. Okay, this is a very popular meme. There is no cloud. It's just another computer. I use it to. I agree with that. Till yesterday. Yesterday I saw this tweet. Okay, is another reference about there is no cloud. Is only someone else's computer. And then I saw this article in ZDNet that says, "Stop saying cloud is just someone else's computer," because it's not. And when you start to read, I have the link here. When you start to read this article, the first paragraph say like that. If you joke that cloud is someone else's computer, it's because the joke is on you. And because cloud is not exactly someone else's computing. It's a little bit more than that. So let's discuss what is cloud computing. And after saw that, I felt like, okay, I'm a joke to you. If we are going to talk about cloud computing, we can talk it in many levels, right? We can go something deeper, as like this diagram, that says the internals of the Azure stack, right? And the part that we have contact is only the Azure Resource Manager layer, right? The Azure portal, basically. But on the top of cloud computing, we have a lot of technologies. It's not because you put a server on the internet that you can say you are using cloud. When you are talking about microservices, the same thing. It's not because you have like only one. Let's suppose you have your monolith, and then you split your microservice in different apps. Not necessarily this is a microservice, right? You just broke a monolith in different apps. Not necessarily this is a microservice. I like to simplify what is cloud for me. We can go like talk about all these computer controller, storage controller, and how the infrastructure of cloud computing works. But I like to simplify. For me, cloud is basically this. You have a request and a response, and you have something in the middle, and then you have your computer computational power, right? Do you know what is these things on the middle? Can you guess? Any guess? Giorgio? And anyone want to guess? For me, it's the best simplification of what cloud is. If someone in an interview asks you what's cloud computing, you can say that. Cloud computing is you have a request and you have a response. And then if your credit card has money enough, you are going to handle this request and return the response. Okay? This is one of the, sounds very simple, but this is one of the core things about what cloud computing is. That's basically you pay for what you use. And basically that. You have scalability. And if you are not using the resource, you are not paying. Okay? Even that resource is allocated for you. Okay? And you put a cloud around, and then you can say like, okay, now I have a cloud computing. If you want to like a more formal description, you can say that a cloud computing is a hyperscale automated computer farm and is run by someone who is better at automation and security than you. And that person can buy electricity, servers, and network connectivity more cheaper than you because they buy it in a large scale. So in a short sentence, cloud is a hyperscale farm that is run by someone better than you and can buy servers more cheaper than you. It's basically that. You don't need to think about how you are going to build your computer, how you are going to build your server. You just delegate this to someone else, and you just focus on your app. What for business and entrepreneurs like me is amazing because I don't have time enough to manage all the infra. I just want to focus on my core business, on the logic of my application, and offer this service to someone else and see if the person is interested to buy it or not. If it's not, I just change it to another project. So if I can deploy something on cloud, right? Based on you only need to focus on the app that you are building. This is one of the core points of the cloud computing. You focus exactly what is important for you. Sometimes, depending on your requirement, what is important for you will be the security. You need more control. So you are going to go for a IaaS platform, infrastructure as a service. Okay. Sometimes you can open hand of the necessity to have more control under the platform, and you can go to a PaaS, platform as a service, or even a SaaS, software as a service. Okay. And one of the options for you to build anything on cloud, you can pick any language. Cloud computing is not dependent on the language. It's the approach that you are using. Okay. So for today, I'm going to talk a bit about Blazor, and one of the reasons I want to talk about Blazor. At ThoughtWorks, we have something that is called Technology Radar. If you don't know ThoughtWorks, but probably you may already have heard about this radar. Basically, we build a list of technologies that are interesting, or we are even using, or we are discarding. Okay, and Blazor is a very new framework, and we are trying in some of projects inside the company. And the reason of that is because even that JavaScript is the dominant language for UI platform, UI development for web, and we'll keep the dominant. I don't think that Blazor or Rust or any other language with WebAssembly is going to take that place. But what WebAssembly provides is a way for you to bring apps that before you cannot build for web, and now you can, right? One of these examples is Google Earth. If you don't know, Google Earth is one of the biggest cases of WebAssembly. And basically, WebAssembly is you try to run machine code on the browser. So you can run any app with almost the same performance than you are running in a native code. This is very interesting. It's very, very powerful. So Blazor is a way for you build your UI, right? You can build client apps. It's going to run on the browser, but it's not going to use JavaScript. It's going to use only C#. And how this works? Basically, when you write your C#, the C# compile it to WebAssembly, and from WebAssembly, you can run it on the browser without using any plugin. You don't need Flash. It's a is a patronization, is a standard for web. And you don't have a problem for this happens. It's not, for a long time, Microsoft technology was looked bad for developers, but I believe this reality changed a lot in the last few years. And I bet that today, if you're a web developer, probably you are using something from Microsoft stack. Or you are using TypeScript, or you are using Visual Studio Code, or if you are deploying your app, you are going to deploy or in AWS or in Azure. And since the Visual Studio Code is the today most popular text editor available, so probably you are using something from Microsoft. And you are also probably, if you are building JavaScript in a large project, probably you are going to replace this for TypeScript someday, right? So how Blazor works and how WebAssembly, how this fits onto the web development, right? When you have a traditional website, you have HTML, you have your JavaScript, and let's not talk for WebAssembly right now. But the traditional process, you have your HTML and JavaScript is going to be served to the browser. This is going to be interpreted by the runtime. And the runtime of the JavaScript, you have three main phases. You parse, you compile, and you have the JIT. Okay. The parser and the compilation is one of the biggest. I don't want to say pains, but is where you lose most of the performance of the JavaScript. In the V8, JavaScript is okay to run. It's pretty fast. But the problem is when you have a web app and you want to start it as fast as possible, you have to download all your assets, and after that you have to parse and you have to compile it. This will take a little bit of performance. One of the main improvements in React recently was to make the startup time faster. For some projects nowadays, the startup time is very important. For example, imagine that you are running some BTS or MRT system, and you have some security. Let's suppose if the train is going to collide in something, you have to stop it, right? You cannot do it in JavaScript. You don't have time. That milliseconds are very important for you. You don't have time to parse and compile it, okay? When you are on web development, some projects also have this exactly requirement. For example, games, or hard, very interactive dashboards, something very heavy in visualizations. Let's suppose you have AutoCAD, for example, or you have Figma for web. You want that this kind of application is very heavily on GPU and also in performance. JavaScript, you can deal with that, but there is better options. One of the options is for you to use WebAssembly. That is basically you are going to compile your code to a binary machine, and the browser will be able to understand that. And using this, you can achieve almost native performance on the browser. So, and how Blazor fits with this? Compile your code for WebAssembly is not really hard, okay? WebAssembly is a very easy language. It's a very easy target for compilation. Today, many languages, Go, Rust, even Node and JavaScript, you can compile for WebAssembly. It's not really hard targets to achieve it. But the problem is that you want to have a very small runtime to run on WebAssembly. Rust is a very, very nice choice because the runtime of Rust is very, very small. So when you are going to run some Rust on WebAssembly, you don't need to load all the very heavy runtime. For C# was a problem. What was really, really a problem. Because if you try to compile all the C# has a very huge class library. If you try to compile all the class library from C# to WebAssembly, Microsoft tried to do it and was problematic. Very, very problematic. So what they decided to do, instead I build from C#, instead I compile to my runtime, instead I compile C# to WebAssembly, I will build a runtime for WebAssembly. That is what you can see here, mono.wasm, right? It's basically the .NET runtime built for the browser using WebAssembly. And then this runtime, the runtime understands native DLL code, native C# code. So what you do, you have a runtime, you are literally bring the power of the .NET to the browser, and then you download the DLLs inside the runtime and run your app. And basically Blazor only help you to orchestrate that and also facilitate you the communication between WebAssembly and the DOM. This part here, the blue one, the WebAssembly part is a sandbox. WebAssembly don't talk directly to the DOM API. Okay, we do it between using JavaScript interop. If you try to access the DOM inside the WebAssembly, you are going to have an error. You cannot. You literally cannot. You need to ask for the browser, okay, the browser to do the access for you. And we have APIs from WebAssembly to do it. So Blazor basically gives you the chance for you interop with JavaScript and use the browser APIs using WebAssembly. And I want to show some nice case of where WebAssembly fitted and why some companies are using WebAssembly. And we have this case study here that they ported a JavaScript app to WebAssembly and it ran 20 times faster. Okay, and this is the power of WebAssembly. We also have a port of the Doom engine for WebAssembly, right? WebAssembly is a very easy target for compilation. So you can compile almost anything to WebAssembly. And what many of the companies are doing, they are compiling C++ and C projects to WebAssembly and bringing this to the browser. One example of this is AutoCAD. I don't know who know this software, but it's a software for mechanical engineering. You have the possibility to draw, like, if you are building a car or any mechanical piece, you are using probably AutoCAD. It's a very famous software. And it's very hard to build that for the web, not because complexity of development, but the target of the niche of the apps, and they are built to run into the in C and C++. It's built for desktop. It is a problem to bring this to the web with the same features and the same compatibility. So what you can do, you can compile the AutoCAD to WebAssembly, and then you can run it on the browser. One other example is Figma. If you are using Figma web, you are using WebAssembly, and probably you do not know yet. Very, very interesting. I have the reference of this post, but it's basically the WebAssembly will fit very, very well into these targets. And one nice thing about WebAssembly is that you can host it in a static website. You don't need to talk with the server. You don't need to talk with the server anymore. You can using a REST API, but imagine you build a game that is an offline game. You can just host that in blob storage without almost any cost, and you can handle like millions of clients. So how it works in Blazor? It's very React-like syntax. You have components, and then you have your route, and then you have your layout, right? And if you do not find the layout, you render something else. On the C# code, will look like something like that. It's literally for who knows .NET Core. This will look very, very familiar for you. You are creating a host for WebAssembly hosts, right? This host will only serve you the static file with the WebAssembly. And then you are saying that your component is the app class, and with the you are using the selector is going to render on the app in a div called app. I have it here. It's going to render this one in this selector app. When the compilation of WebAssembly is done, it is going to replace this by your app. Very, very React-like. So you are only doing some dependency injection. And here I am setting up HTTP client to talk with my server back. In the moment that you are building, even that is C#, you are building for the web. Your code is running in the browser. You don't have the server anymore. So if you need to talk with the server, you need to talk with REST endpoint probably, okay? Or you can use some real-time connection as well. So when you compile this, when you deploy this, you have exactly this structure. You have a file, index.html. You have your CSS, and you can see that you don't have like a JavaScript. Literally, this site here, there is no JavaScript. I'm running everything in WebAssembly. And inside the framework, what you have here, you have DLLs. That is basically machine code, okay? These are C# compiled. If you are using C or C++, you are going to have a header file or something like that. Okay, this is compiled already. And your HTML, you are basically loading your CSS, and here you are basically loading the Blazor WebAssembly that will start the Blazor, will start the WebAssembly and everything else. And when you hit that endpoint, you can see the request here, and you can see a bunch of DLLs being streamed over the wire, right? So your Blazor is downloading DLLs from the server or the blob storage or anything else. I know it's a little bit small here, so I try to put a zoom here. You can see like C# class generator.dll. This class generator is my project, right? We have a web DLL, and we have some HTTP client, some other dependents. And this will be the results. You can check. I have a link for this app, but basically this, what is the idea? You put a JSON, right? I have this problem is very frequently on work, where I need to consume a REST API, and I need to generate my models for that API. So what I did a kind of reverse engineering. I pasted the JSON, and then I generate C# classes from that. So if you enter like a JSON with name and age, I generate a class for you with the proper string name and int age. And how you do to deploy it to a blob to a storage account, right? You can do it not necessarily in Azure. You can do in Amazon as well, AWS. You can deploy it to S3. You can find many tutorials on that. So you create a new resource, a storage account. You put basically the name of the storage account, okay? And you select the location where your location is going to run. You also can change, if you change for premium, you can select that is gel replication. You can select more than one regions, and it's very nice. And the only thing you need to do, you go to the property, static website, and enable it. And after that, you do the deploy. If you wanna check, you can check on this QR code, and we are going to see the app running. It works on mobile. So yeah, if it works for you, you are running C#. Let's see. Yeah. Okay, yeah, it's literally you are literally running C# on your Android phone or iOS. This is very interesting, right? Imagine that all the projects that you build, desktop, something like that, you could very easily port it, compile it to WebAssembly, and run it on the browser with almost with performance almost like native, right? Imagine how many apps you can bring to the browser now using the power of WebAssembly. And why host a static website on a storage? Okay, I do it a lot with my single page applications. As I told, me as a single developer, an indie developer that is trying to create a business, two things are very important for me. One is how much I pay for my software, because I need to hit the break even, right? I cannot pay like thousands of dollars a month to host a website that is giving me like hundreds of dollars. Maybe someday in the future, when my revenue increase, I can build something more sophisticated. But if I want to try, or if you have like a blog, or you have any static web application, you can very easily host on a storage account, and it's very cheap, and the performance is almost. I will not say that is the best performance that we are going to have, but will be very hard to beat the performance of that. And why you should host static web apps? First, you have no capex expenses, right? I don't need to build a server. I don't need to put it in Apache or Nginx. I don't need to care about cache or anything else. All this is given for me for free, okay? Capital expenditures, yeah. Basically, we have two kind of costs: OPEX, operational expenses, and CAPEX, capital expenditures. That is basically when you buy a server or you do like some upfront investment. So I don't need to buy a server. I don't need to maintain that server. I just deploy to my blob storage, and I ask for the blob storage replicate for across all the world. So any place that you access, you are going to have a very good latency. Another thing, scale up automatically. will be almost impossible you shut down this. You cannot do the DOS. First is a static website. Second, I'm hosting in the blob storage of Azure or S3. You cannot do a DDoS on that. If you have like hitting a server, you can, but not in a blob storage. You have high availability. Okay, I have 99.99% of uptime a year, and I pay 30 cents dollars a month. Like, yeah, yeah, zero, like, yeah, 0.3. Yeah, mine is 0.3. Yeah. Yeah. Oh, I'm having 10 times more cost than you. Okay. But okay, so my thinking is okay. I need to build something to try to make money as indie developer. What is my cost? 0.3 cents, $0.3 a month, right? 30 cents a month. Anything that I do if I put ads, probably I'm beating my costs already. So I'm literally making profit from a single page application. You have fast content serving. Your blob storage will be replicated across 32 regions. And if you ask in Southeast Asia, you are going to have, there is a CDN that is going to copy all the assets to Southeast Asia. If I go to Brazil or North America, you are going to have all the same latency. And it's time saving, it's money saving. I don't need to care about like later enough. I just build my code. And if I need to talk with the server, then I use serverless. My 30 cents, $0.3, I'm already included serverless. I have 1 million requests for free, right? So in the moment that I start to pay, like if your website has like more than 1 million requests a month, probably you are already making some profits of that. And you have like very illusory costs. So the idea you build apps, and then you are going to have like small profits from this app here, small profits from there, small profits here, there, and then you are going to build like over the years, and you are going to build like something that maybe can generate you a passive income. And so, if you do not understood nothing of this talk, is not. I am from Brazil. You are from Thailand, and we are talking English. So probably there is some problem of communication here. But if you do not understand, one thing that is very important, you can resume this talk about all this. There is no point for you to use microservice, cloud computing, Azure, AWS, if your software has a single point of failure. Okay? What it means? If your software has a if you log it to your file and your file is full, your application crash. Okay? AWS microservice will not solve this problem. You don't have a problem about your PIs, your architecture. You have literally a problem because you are building a solution that has a single point of failure. But if you move to cloud, if you move to Azure or AWS, maybe this will give you money, will give you time and money enough to try to fix the real problem. And one very, very important thing, if you want to take the benefits of cloud, you have to design things to achieve that. These are some reference. You can check the source code, and you also can check some nice talks. I put one here, very interesting for you. That is a series of talks only focused on microservice, and also if you want to do replicate, at home, you can follow this tutorial here that will teach you step by step how to deploy something on storage. And thank you very much, Kapuna Kap. Questions? Yeah.
Yeah, of course. Thank you very much for the talk. But of course, when a solution is too much perfect, I have many questions. First question, I have 3 questions after I will leave the micro. First question is, okay, you don't need thousands of dollars to run it on your server.
Not yet.
Yeah, not yet.
Yeah.
But when you will be successful, maybe with CDN, you will need it.
Definitely.
But my question is, as a client, if you improve your application, I mean, as a user, do I need thousands of dollars on my personal computer to be able to run your app? I mean, what is performance ratio on the browser? I mean, for the user.
For the end user?
Yeah.
Pretty much okay. If you can check like one nice thing to check the performance on Google, you can check the performance of websites, and one of the things that puts your performance down, your degree, your note down is performance. So this is a very, very nice thing. Another, I can handle for you anything below 100 milliseconds.
Okay.
So for me, like the target's 100 milliseconds, pretty okay. And I can change like from VPNs. I can change from my machine in Brazil, and I can have the same 100 milliseconds. So in question of performance-wise, I believe it's pretty much okay. Because I literally do not have a server, you know. I am literally only giving you static assets. That there is no. It will be very hard for you to beat that performance. Even if you put like a single page, if you put like a web server, Nginx, only to give you like HTML, probably I'm going to be faster than that. And I'm getting like CDN for free as well.
Okay, I will not hold the microphone too much. So second and last question. I noticed that some of your screenshots show Finder, so I guess you're on Mac.
Sorry?
You have some screenshots from Finder, the Finder application on Mac, I mean. Okay, no problem.
No.
Do you know if you have some plugins on Rider or anything like that to help you with Blazor development?
You don't need any plugin. You mean to run or to build? Like
to build it.
Okay.
Like when you want to build it, for example, on Mac OS X or on Linux.
Okay.
Because of course, I'm pretty sure on Windows you have plenty of tools.
Yeah.
But question is more regarding Mac OS X and Linux.
Yeah. Okay. The development stack. I use a bunch of Visual Studio Code. There is an extension, Blazor extension for Visual Studio Code. Will give you almost the same development experience than build a React app. Some of other extensions more for C#, some linters, because behind of that, you are writing C#. I recommend you, I do not use Rider. I use Visual Studio Code for Mac. I code in a Mac. But I need to be honest, the experience in Windows is still better. At least for if you use Visual Studio. And I also use IntelliJ products. Rider is built on top of IntelliJ, JetBrains stack. But I still not use it. I prefer the shortcuts of Visual Studio. I have been using Visual Studio like for 10 years, and even that if I go to Rider and change the shortcuts for the Visual Studio, it's still not the same thing. Yeah. Yeah, it's Giorgio.
Okay, that works. We have the full stack and React.js, right? Developer. You're the mobile, yes, okay, but I don't speak about you. Is the how can be integrated the Blazor and the WebAssembly with the, for example, a React.js application?
Okay.
If you want to make easy,
no,
you can say AngularJS, as you go.
There is a simple question and there is a bit more complicated question, answers, to be honest. The simple answer is, for me, let's suppose if you have a React app, in my opinion, do not make sense build a Angular component inside of that React app. I really strongly recommend you, okay, if you started with React, keep in React. If you know, it will become like an anarchy. You have you can build like a micro frontend, it is pretty much okay. But imagine you have an app and then you have your header. Imagine one single page, your header is Vue.js, and your footer is React, and your body is Angular. You know, like, how do you pass data between these frameworks? You know, like, you serializing JSON, you put in the global scope. So if you put Blazor and React, you are going to have the same problem. They both are two different frameworks. You can build a single page application with both. You'll be pretty much okay. But you can mix them. Yes, you can. You should mix them. Not necessary. But one thing, for example, let's suppose you have ASP.NET web application, and then you coded C# your entire life. And you need to do some components to add some interactivity on the app. I think Blazor could be a nice choice for you. In this case, I think it fit well. And all the things that I told about, like put single page applications on the blob storage, not necessarily have to use Blazor. Okay, my strategy is like try to keep as cheap as possible my costs, and I try to build as much apps as possible. And then few of that apps, I realized that I have some customers and they keep coming back, and so I invested on that apps, and maybe someday I want to make it grow. But my idea is like, okay, nowadays I have like 5 apps with 100 of users, and few of them is growing and few of them are not. So I discarded the crash that I call, and keep focus on the apps that I see a future on that. Okay? No more questions? Thank you.